Okay, we're live. Okay. So you should be able to just start, I think. I will go to my computer and make sure it's working, but okay. I think we're good.
Is that legible? Okay. Can I see what the screen is?
There's a little delay, but
okay.
So
it's that and
it's that, but then blow it up. Okay.
So they don't even get to see me, huh?
No.
That's good. Put my head back on. My head's cold. Okay, so I'm Clark, and I sit on the other side in the DSI. I work with Duncan Temple-Lang, the director here, and mostly do work. I'm a third-year PhD student in statistics, so my background is stats, but I really like the computing aspect of things. So with Duncan, I mostly look at things about extending R or different systems. Lately, it's been looking at GPU programming, graphical processing units, so it's extreme parallelism, fun stuff like that. So I'm a techie. But before that, I worked at Cisco Systems, and that's when I really started getting into this shell stuff. We have clusters that I would work on, Hadoop and those sorts of things. So and I think that's the biggest reason to be thinking about using the shell, is if you're working a lot on remote servers. So here we're looking at my local desktop, and this is how I use R. I'll have like a shell open and then an R prompt open. So on the right-hand side, this is my normal R thing. I can do all that. And here, this is just a shell. So I type ls, I get that. And I edit my text files here. And the reason I keep everything like this is because initially when I started using servers a lot and different programming languages a lot, then I realized if I was stuck in an IDE, then I was worthless on a server. It was hard to translate those skills or that workflow over there unless you get the server to support the IDE through the browser, which RStudio actually does very well. So that's a nice thing you can get. And you don't have to do it like this. It's just when you work with different languages and when you can't assume that something is installed on a server. For example, these larger production servers where you can't offer on it, you just have to use whatever's there. So I'm sort of going to the lowest common denominator of the things that are always there. And that's why it looks like this. And the reason I do it locally is because then I have exactly the same set of tools and experience on my local machine as a remote machine. And this makes it so I can't tell if I'm on the local machine or a remote machine, which is very good for me. It's just easier that way. Yeah, so the shell, the way you can think about it is I think of it as really the lowest common denominator for any programming language. So all programming languages have some way to interact with the shell. This is sort of the first thing you would have. On top of that, they build things that are easier to use, like GUIs, where you can click around and move things and do common things much easier. So the reason to do it is to just kind of extend. And let me give a little more motivation for other reasons. Let's see. Okay. This is the R thing, so do a little R scripting. So we're going to draw my graph of productivity. can see how this works. So I have a thing that does some graphing. It'll make my graph. So I can go like this. I can do PDF. If I want to call it, say, graph.pdf. Okay. This is an R script. It's generating a PDF. I run over here, and so this is how you run it from. Well, let me show you how you might run it. So you might take R. You might take the R console, and then I have this script. It's called productivity.r. So I could go something like source productivity.r. And I don't have that graph PDF. It's not there yet. So I can do this, and that's, apparently nothing happens. But I should see. I should now see the resulting files that I wanted here. So if I quit out and look at it, I see it was called graph.pdf. So I can open that graph.pdf, and there it is. Okay. So here's my attempt to motivate it. So often when you're clicking, if the tasks you're doing are maybe not that hard, or they're not on the server, then going through in like a very easy to go ad hoc fashion is really nice for getting started. That's for sure easy. And at first, this doing everything by the command line and making it all do that, it's not worth it. It's absolutely not worth it. And some people, like myself, have tried. I've gone the wrong way with this. I'm like, okay, everything has to be super rigorous. I'm just gonna makefile everything, and it's gonna be like the most rigorous and disciplined workflow in the world. And then it just takes me forever. It ends up evolving to something else anyway. But after a certain point, there becomes a time when you cannot do things with the GUI. You have to get into the shell to do some other things. For example, accessing environmental variables in your system. There's ways to do that from R, but if you really want to get in there and manipulate things, you need to just have that direct contact. So that's a motivation for getting. So once you're here, you can't do it in the GUI, but you can do it with the shell. So you're way more productive. All right, that's my graph. So let me demonstrate how to make this graph without, say I want to name it something else. Here I've called it graph.pdf, but say I want to, and this is the other way to do it. Actually, we'll start with this. So instead of R, so before I open the R interpreter and I press source, this is almost exactly, well, very similar to the same thing. From the command line, I can just go R script and the name of my script. Familiar with this? Have you seen it? No. Okay. Okay. So the other way, so this did almost exactly the same thing. Okay. We'll see the differences. They're not important.
Is RScript a function or a command that's just built into the command line automatically? Like, how did you get the shell to recognize how to read R code in the first place?
Excellent question. It felt like that was a planted question or something. Something I meant to cover. Okay.
Maybe repeat the question too.
Yeah. So the question was, is it something that's just built into all command lines? Does it happen when you install R, or where does it come from? So these are things that are built into the command line. Things like ls, that's list the files in this current directory. Okay, so I type that and it happens. But if I say which ls, you see this. You see /bin/ls. Okay, so I can do /bin/ls, and it did exactly the same thing. So this was me calling the command directly by the absolute path. Right? So this ls is a convenient alias for the actual executable, which is /bin/ls. So this is how your system does things. Inside this bin, if you look inside this bin, there's all these executable things like make dir, make directory, make a new folder, remove dir, remove that directory. So all these things are pretty much built into your Linux or Unix system. So the same way we did which ls, we can go which r script. Okay. User local bin r script. So instead of being my actual system bin, this is in my user local. So this is something that's specific to me or the users on this machine. Like not all Linux machines will have this. So when you install, we'll take this R script and link it here. So it'll make this shortcut so it's in your local bin so you can find it and see it and use it. And understanding this is really key to troubleshooting why things don't work when they don't work. For example, you'll type some command in and it won't work, and this is generally the reason why, because it can't find it. That's my experience almost always. So how it does find it is something called the path. Okay, so this is a system level variable. So this is a variable that exists within the system, not within R. It's totally separate from R. But any programming language or any program like R will go and use your system level path. And this says, where do I look for executables? Where do I look for these binaries? So, well, let's just demonstrate kind of how that works. Okay, so let me see. How about path equals nothing? What do you think this will do?
What export means.
So export means like set the variable. It's like setting equal. Yeah.
So it's gonna clear your.
Maybe it didn't let me do that, or. Okay, so say I just want slash user slash bin. Does that work? Yes, okay. All right, so this is going to be the way to, you can see that. So now if I look at my path variable again, it should have changed. Path, okay, it's not there. So the R script was in user local bin R script. Now the only thing I have in my path is user bin. Okay, so when I go to run the R script, let's see what happens. Command not found. So this is naturally, this is what you expect. And when you're installing new programs, this is a common thing. So it's usually, this is just what it means. You can't find it on the path. Because in this case, I've intentionally destroyed my path by doing this, my path variable. And on the left-hand side, what I'm looking at is where I actually set my path. So,
So you can get it back.
yeah, so I can get it back, and because I want it the same for different systems, and I try to do different things sometimes, so I sometimes intentionally set it. Okay, so let me see if I can get it back. Wonderful. Okay, so it's back, and now all my stuff should work again. Which R script, yeah, it's back.
How did you get it back without having? Did you run export on that side?
So what happens? I'm using this thing called TMUX, Terminal Multiplexer. You guys, you're nodding your heads like you're familiar. You've seen it. Mm-hmm. Yeah. Okay, half the people have seen it. So you definitely don't have to do this. It's with the IDE, you get the ability to have different windows and panes open and look at things at the same time. Super handy. With a regular terminal, you don't get that. You can't. You just look at one thing, and if you execute command, it's running. And what do? You know, you just wait. So Tmux makes my terminal act more like an IDE. It gives me multiple windows. I can scroll through the buffers. So if I want to kind of look up and see what else, that's a new one. Right here, I can actually scroll up through the buffered window and see things. Yeah, I mean, it's not a critical part. It's just it's a thing that's on the server. So what I did here is I made a new window, and whenever I make a new window in my Tmux, it's sort of like when you start a new terminal, you get hopefully some reasonable defaults, which you can control, by the way.
Do you prefer CMUX over Screen?
Absolutely.
I was just teaching. We were teaching some Bash stuff this weekend for genomics research, and teaching Tmux to people who have never worked with a terminal before was a little rough, but Screen seemed, for whatever reason, seemed to be easier.
Really?
Yeah. So I don't know. I was just curious.
No, I think of Screen as being sort of a strict subset of the things you can do with Tmux. Yeah, I mean, you can make Tmux act like Screen.
Right.
And the program he's referring to is the reason people use it is when you log on to a remote server terminal session. If you're doing stuff, you like to be doing stuff, execute commands. If all of a sudden your connection drops because you're on a coffee house Wi-Fi or whatever, and you lost your connection, then you don't want to lose all that work that you were doing or kill all your commands. That will happen with a regular terminal. It'll just all die, like you had killed your thing. And with Screen, it attaches it as a kind of a background daemon process that continues to run. So you just log back in and attach to it and say, oh, okay, there it is. So let me show you right now what I mean by that. So that was me detaching from Tmux. So now I'm back in my normal terminal. This is just a totally vanilla normal terminal. But if I go and log on to a remote server, so by the way, do not nest your Tmux sessions. It's the danger zone. So now I log into a remote server. I'm just a normal server login. If I kill this right now, all the stuff will end. But if I attach to my Tmux session, this is a thing, the session that I had before when I was preparing stuff for this talk. I had the session open, had all my windows open, so I just go right back to it. And this is extremely convenient. And it's the same thing that Screen does. Tmux just gives you the ability to have a whole bunch of different screens on here to see what you're doing. But the other thing is Screen is kind of always there, I think. Tmux you have to install. It's not there by default. Yeah.
Yeah, we found that out too. You install it on the server or on your local?
Both. Yeah. And they're not mutually required. You can. Yeah.
How do you spell it?
Pardon?
Tmux, MUX or MUX?
TMUX, yeah. Yep. So yes, it's my favorite tool for working with the server.
So you're using Tmux right now, that's where you can split.
Yep. That's why I'm able to split my.
I didn't do that in the terminal thing, and I could see the tabs, but I couldn't get the tabs. So.
Yeah. Yeah. So there's different solutions. I mean, there's a lot of good ones out there. I mean, Emacs can do similar things. I'm not totally familiar with that, but all right, where were we? Back to R stuff. Oh yeah, that's right. The graphing stuff. Okay. So here's that script that made the graph. So suppose I want to pass a command line argument into the script to give the name of the file. So the reason you might do this, you might have a directory full of data files where for every single data file, you need to process it and make a graph depending on that. And it might take a long time to do each one. So that would be a case for making it all run from the command line. Then you can just set it up to run and leave it and forget about it. And you know that they'll run independently, which is something I've been doing recently with the GPU programming. This is very important for me to get them to run independently, because I know that I'm using memory on this device. I want all that memory and all that resources to be totally filled up and independent between runs. So one way to get it is to execute the things kind of with command line arguments from the command line. So let's take a look at these arguments. So here's the default. Okay. So my R script is back here. So R script, the name of my script, and I'm going to pass it some arguments like hello dude. Okay. So this is what happened. So this was the script, print the arguments, and this is what we see. So this is the actual executable that our script points to. So our script links to that, and that links to this executable in some way. So the differences between normal R are these arguments here, these dash dash. Some you might have seen in, I think you can dash dash vanilla in there if you want it to not use a startup file, things like that. That's useful for simulations. So the slave, we don't have to go deep into this, but that's like if you were setting up a cluster, this is how the clusters will set up themselves. Or even multiprocessing on your own machine. This command executes and makes slave workers so you can do multiprocessing. It's the same concept, the same argument even. So these are arguments to kind of R itself, but below this args are the ones that I passed in on the command line. So these are the ones that I care about. So if we look over here and look at the trailing only, so we can change this to true. Same command again, just press up. Hello, dude. Now we see only the ones that were behind this arg. So these are the things that I meant to pass in. So if you're passing in arguments to a script, this is the way to do it with the trailing arguments there.
So when you say passing in arguments to a script, so it's like you can append command line arguments to an R script to make it do additional things that you wouldn't be able to do in R alone, or to make it more convenient to do things.
Yeah, it's more to make it convenient.
Okay.
Yeah.
So like, can you give an example of practical use of command args within R scripts?
Yeah, so I was talking about the GPU one. Pull that up. Yeah, let me just pull it up and I'll show you. Okay, here we go. So this is the Julia language, but it's exactly the same concept. You have these command line arguments that you pass into it. So this is the thing that I was talking about with the GPU. I wanted to try these different numbers and see how they worked with the thing. So it was very convenient for me to pass them in as a command line argument in this way. So that's a practical example of how I might use it. But another maybe more practical way is if you're building a tool for someone, and if you don't know where their files are, if you're not using the same system, I mean, you can't know where their files are in general, right? That's totally unreasonable. You don't even know what system they'll be using. So it's nice to be able to give them things that work like this, because that way, they have a self-contained tool. Otherwise, if you hard code it in, then they have to actually modify it modify the script rather than passing it in as an argument. And conceptually, you want those things to be different. You want an argument to a function to be one thing, and you want changing the actual script and program itself to be a different thing. So this is how you would use it for this one. So this is just showing you the basics. So this is the way to actually do it. So instead of having the name, force it to be graph.pdf, I just take my arguments out of here. So now, if I want to call it coolgraph.pdf, I can do this. And after this, I expect that I have a cool graph. Yeah, here's my cool graph.pdf. Okay, so that's how you allow it to pass it in. So the idea is making tools. It's one concept. Yeah.
Sorry, the first question was about how the trailing only true versus false. It seemed like my expectation was it was just sorry, can you describe what trailing only does again?
Yeah. It's doing great. So these are the actual commands that got executed. So if I was to take these on the command line and take out the quotes and just concatenate them all together, it would have exactly the same effect. That's what happened. The trailing only just said, I only care about the ones that are behind the args, because those are the ones that I will use inside my program. So,
but it looks like it, instead of having those two separate entities, it combined it into one entity. So now hello and dude are, oh, never mind, got it.
Yeah, this is just ours printing. It detected that they were strings for that long. So,
and sorry, another naive question. So one example, I think I mentioned, I spend a lot of time modeling wildlife movement from one point to another point.
Mm-hmm.
So if I have my code that has many different points, and I don't want to hard code it in which point the model is going to model. So sorry, the script will require for me to put which point I want to connect to another point, so point 10 to point 15. So then I can use those as my two arguments, 10 and 15, and I can say run the script connecting point 10 to 15. And
absolutely. Yeah, that's a great example, I think. Mm-hmm. But if you really want to do a whole bunch of combinations, then you might be better doing that in R itself versus Bash. Yeah. So I have a more involved example with Hadoop. I can show you, but Mfanoe asked me to do a couple other things, so and also there are a few other things to remember here, or just to know. How about this counter? Okay. All right, so here's another R script. So this is very related, which is why I want to show it now. So in the same way that we put the R script command in front of these, we don't have to put the R script command in it. You can make the script itself executable. So what I mean by this is you can probably, actually, I don't know, you should be able to double click on this and have it just run. You don't have to go through the terminal or anything. But I would have to double check on that. But what it means is, for me, if I run the counter script, this just concatenates 1 through 10. Okay, so instead of doing the R script, I did the /. So I made this thing executable. So there's two components to this. One is putting this, they call it hash bang, the hash being hashtag, and bang being the exclamation point, the hash bang line, user ben end. So that says this user ben end is look for this particular user, see what R script they're using, and then use that one to execute this script. So, and this is kind of the by the book way to do it, why I'm showing you it. And the other thing you have to do is make it executable. So you change the file permissions to, you have these read, write, and execute. That's how file permissions are controlled. So I can make it executable by doing this. If I go, well, by default, things won't be executable. So let's just counter.r. Now if I try to do it, this -x, it takes away the ability. Never mind. It still works. Huh? Oh, yeah, that's right. I had a Python one that does the same thing. The world is sane again. Yeah, permission denied. So I didn't have execute permissions on the script. So this is something to bear in mind. And this -x took it away, so the +x will add the executable ability, the ability to execute it. Okay, so
What's there's a number combination too that does the adds instead of +x or r or whatever.
yeah,
There's like combinations of numbers. I remember using them and then I've forgotten them, so.
yeah.
Do you find you use those?
No, I think you did well to forget
Yeah.
that.
Could you explain that first time, hash?
Hashbang?
And is that related to the changing permission settings that we did? Or are they two separate ways of doing it?
Yeah, they're two separate things. So maybe it would be best to look at this in contrast to the Python one. We can see what the difference is. So here's a Python one. The Python script looks pretty much exactly the same. But here I go in my user bin end, and I say, use that to execute this script. Okay? So I go over here, and I do /counter.py, Python one, it works. Because it used the Python interpreter, it used, so if I do this /user/bin/end, this is, I don't know, I think it's just a convention to where Bash will look at your first line and say, if it looks like this, then I know how to use that to find programs. So user/bin/end Python. Okay, so this opens my Python interpreter that I use, just like the R interpreter. But if I try to use something like the R, this is wrong. This is not valid R, it's Python. So if I try to run it again, it's an unexpected symbol because this is not valid R. Python. Does that help at all, or?
It does, yeah. And how do you set a shortcut so that you can type in the dot and slash and then it executes it? How do you set that?
Yeah, so this is just the shortcut, if you will. I mean, the // the // means to run an executable that's inside your current directory. Okay. So I keep using the executable ls. If I go which ls, bin/ls. So if I go to this place where it is inside my bin, so this is my system level bin, and I pressed ls and it used the normal one. I can also go // and that says, look inside this directory, pick out the ls command and do that, run that system executable. I think it's the same result. So this // is a way of being very specific about the command you want to run. It means the one that's in the current directory. Okay, and you only need it when you're in your current directory. Otherwise, it would look on your path for it. Unless you put your current directory on your path. Which is, yeah, probably shouldn't do that. So, okay. I think you can just jar shell counter.r. So I think in this way, yeah, that works too. So I just gave it a relative path from where I was. to run that command, basically. It's a script that's acting like a command, kind of. Okay, let's move on to some other, or any other questions about this? Yeah.
A really basic question.
Yeah, no, please.
I'm trying to execute some R scripts in the terminal,
Uh-huh.
or not R scripts, but just R functions,
Mhm.
arguments, just like we did very 1 through 10 or something.
Yep.
And it's not working. Do you have to type R script first?
So R,
Just type R.
yep,
There it is.
Yep.
Yeah, okay.
yep. And if we look at that, the same sort of steps, which R, just like that which R script,
Yeah.
it gives me an executable, so that says launch the R interpreter. And let me start typing in my commands to the command line.
So if you wanted to actually make an R script that did stuff, you wouldn't do it here. You'd open up like a text file.
Yes.
And then
Yeah, so yeah, and I edit all my text files inside the terminal rather than opening another program.
Is that the Vim command?
Yeah. Yeah, that's Vim, or Emacs, or Nano.
Yeah, that's a good start with.
Yeah, if you start with Vim and Tmux, like get ready for a rocky road.
It's a little bit.
Yeah, you just do it when you don't have to be really productive. By the way, that's when I did it.
You don't care if files.
What's that?
Files disappear.
Oh, yeah.
Deleted that you're like.
Yeah, writing all over stuff.
Yeah.
Other questions? Okay, let me do some other examples. So Fanwei asked me to show you this. And this, so what this does, if I look here, I have, remove that one. I have some text files and I have an R script to process them. So the task here, the high level task, is to take these text files, concatenate them into one big text file. So this is one way to do it. I'm not saying it's absolutely the best way to do it. It's, hello, welcome.
Sorry to interrupt.
No problem. Yeah, this can be, I mean, it's, please ask questions and interrupt me. It's just a few of us here. It doesn't need to be super formal.
It's never.
Okay. Sometimes I get these discussion sections in here and the undergrads are like, still want to say anything. If I start calling on them and asking questions, I hate that. Okay.
Okay, so this is a script to concatenate a bunch of files into one.
Yeah, so take all these files, paste them together. That's all that is happening here.
And that captures in essence, that this section is what you actually send to the terminal.
The which one? The
The sprintf. And
sprintf?
after that, the apostrophe.
Right. Yeah. So here I'm calling system, not system 2. System 2 is sort of the more modern one. It lets you pass things in as vectors, but system is just like you construct the command. You build all the strings together and you paste them the right way and put them in. So this is something to be, this is like a little bit, be careful with this. I mean, certainly don't run system calls that you're not totally sure of, because it's a security risk. You can type in any system call to your machine, which is not a good thing. You know, remove all your local files and cause all kinds of damage. Yeah, so this sprintf just makes the string. And so we can maybe just to see what it does, we'll go like that. So this is why you might want to do this. You can do all this from the shell itself, from bash itself, and you'll find that most of these things you can. But the problem is when you do it in bash, it if you've ever read Bash, it sometimes looks like a terrible, terrible language. In that, if you're looping and ending and if and phi and all these weird little things. I mean, it had its time. It was designed in the 80s or 70s, 60s, whenever. And it's great, but it's not really that good for programming. For programming, you're so much better in a scripting language like R and Python, just to keep your sanity, keep your head on straight. So the way you do it, you can combine sort of the system calls with an R script to do the data processing to get the things that you want. So we can just run through these commands line by line. Okay. Just to be clear what's going on. All files. Okay, so I list all my files in my current directory. So I'm passing that dot, that's the current directory. And I find the ones that are text files, print those out. I define an output file where I want to concatenate everything. And then I concatenate them all there. So I call the system cat command. So go back to the system. So if I go cat a.txt, 1, 2, 3, that just print out the content of that file. Those are the numbers, the lines inside that text file. Okay, so word count, I look at all this. So all these have 3 files in them. So I just want to loop over them and concatenate them all to my final file. So I can run this with something like RScript, name of this thing, concat, cat.r. Okay. The lights, did we lose the lights?
Yeah. Oh, but your screen's a lot brighter now.
Oh yeah, is that actually better?
It's weird.
Oh, they're on a timer, yeah, they dim. I'll do the back one.
Oh, yeah. Too much. Oh, I see. You know what happened?
Yeah, they have too many things.
I got caught in a loop, infinite loop. Yeah, careful with those things. Because it grepped through it, find the all.txt and kept concatenating it into itself. That'll go on for a while. And which lets me show another great feature of this, if you're doing this in the shell. So we see I have this all.txt. This is the thing that caused my infinite loop just there. I run it again. I get caught in my infinite loop. So this is what I do all the time. I do something crazy, and then my computer is totally frozen. I can't get out of my terminal. So a nice thing about having these tools like Tmux, I can just kill it. I can just send the command and say die. Like, I'm killing you. You're dead.
What command was that?
Yeah. I mean, it's equivalent to just closing your terminal.
Yeah, but what did you actually type?
In Tmux, it's Control B X. So Control B is the prefix key, and then X is like kill this thing, which just a handy little trick to have up your sleeve that I use way too often.
I feel like you were in that same line with Control C.
Yeah, right. That Control C, but that Control C I think won't work with if you're in compiled code.
Okay.
I think is when it oh yeah, so now we can see what actually happened if I call word count. So this word count is looping through and counting all the lines and all that. So it ran for a few minutes. So that means there's an ungodly amount of lines in here. I'm kind of curious now. I just want to let it
We
stop.
usually do word count lines. Right now it's counting all the words.
Oh yeah, word count -l.
Yeah.
Well, there's only one per line. So okay, here we go. So in that amount of time, it got to 57 billion. Okay, so there's my big data right there. Make my own big data. Speaking of big data, what do you guys want to see? You want to see streaming computation in R, or do you want to see Hadoop type data movement stuff?
What's the difference? I haven't really used either.
So yeah, that's good. So the idea of streaming computation is this file that I just accidentally created that has 57 billion lines. You can't read this into R. R doesn't have the memory to allow it. I think there's a few packages like Bigtable and Big.table. I forget, I don't really use them that often, but they're very nice for this sort of thing. But in base R, you can't do it. But one way to do it in base R is to stream through it. So R's normal programming conceptual framework is that you have a vector. It's laid down contiguously in memory. So my machine has 16 gigabytes of memory. Once you go outside those 16 gigabytes of memory, it's not going to work well at all. You swap to disk, so it uses the disk as kind of a virtual memory, but your performance just completely dies, and it's very likely that your R will just keel over and die too. So the way to do that is to not read it all into memory. And a lot of times you can avoid reading it into memory. For example, with this, if we look at just the head, so I take the head of these. If I was only interested in those observations that I know they start with something, I know that they start with 9. Conceptually, I can do it. I can loop through, say, does this start with 9? Yes, I want it. And maybe if you do that, you might reduce the size of the huge data set. You do the filter operation. This is a filter operation. You might be able to get it to say 1% of the total data size. And that might be totally possible to fit inside your memory. And like, great, okay, cool, let's do it. So the way to do that is to stream through the data, which is something that it's not really something you do every day in R, but it's a useful skill. And one way to do it is to combine the shell and a pipe with it. So you open up a pipe and just use the shell command to write the filter, and then get them out of there. So that's what, Mifano, you and I were talking about the pipe. That's what you can do with the pipe, one of the things you can do. So I can show you how to do that. You interested? Yeah? Okay, let me show you. It's not a big deal. It's not, all right. Okay, but I made this sort of example. It's a little artificial, but it's the same idea. So here's my my larger data set that I would like to stream over. So there's this bignormal.txt, u-8 bignormal.txt. So this is a text file that's around 2 gigabytes. I would prefer to not load the whole thing into R because it's going to take forever, and it's 100 million observations there. That was a word count on it, so I just generated them from R and wrote them here as an example. But I have used this on data sets like the New York City taxi data sets. I use this to do some computing on it, or the same idea anyways. Okay. Okay, so this is all it is to read this in using a string.
This is an R script.
This is an R script, yeah. R script, it's calling a system grep. Okay, so if I do this grep $2 normal.txt, okay, so this is a valid system command, go flying through. All right. So this is what the system command does. It processes this as a stream. It loops through every single line. The caret says start at the beginning of the line, match that. If it starts with 2, then print it. So the way I wrote it there, I just omitted directing that output anywhere, so it's just coming up to standard output to my terminal. But it's streaming through, and you can literally see the streamingness of it.
So it's not touching.
Hey, it stopped. Wow. Awesome.
It's not touching your memory at that point.
Yeah, that's a good way to think about it, that it won't touch your memory. And that would be good to check, though.
Or it's touching the memory for just one
One line.
line.
One line, yeah. Yeah, so when you do this sort of concept, especially with one line, the effective result is that you're using only the memory of a base process, like the minimal memory that you can do, and looping through the whole thing. You just keep replacing that object in memory. But while we're at it, I'll show you how to check, because it's good to know if you're destroying your memory, which another thing I often do. Can't close Chrome, which takes a ridiculous amount of memory. Because okay. We're screencasting, so when I'm looking for the R process, I'll find it. Okay, R. So here if I want to actually see what I got, I want to pick those things out. So I'll execute the script, just source it, stream.r. Okay. So now it's running, this stream thing is happening, and I can go back to my activity monitor. So this should be doing a lot with my CPU. Okay, now grep, so it redirected. It's actually grep that's doing all the work. And using all the memory, probably. I guess it's building the vector in R, maybe. So here we go. Here's one that's getting process ID 5851. Yeah. Okay, so grep is done, and it's just R. Go back here. This is done. Length of X. Okay, read.table, did that not work? I'm scared to print it. Class. Here we go, good. It's a data frame. Read.table returns a data frame, that's right. Yeah. Okay, so I have about 2 million lines that started with 2. So I filtered down from the 100 million into the 2 million. Yeah. So this is a way to use these tools to get something totally new, totally different that you couldn't do with base R. So a little more about this. This read.table, you can pass it a string, and it interprets that as the string of like a file name or a connection. You know, you can go HTTP, whatever, read it from the internet, that sort of thing. But you can also use something that's like a file-like object, and that's what this pipe is like. It's something that just knows how to produce lines. So we're using it as a file-like object. So you open it with the pipe, then when you're done, you close it generally. And this is something that's not at all specific to R. All the languages I've used have some mechanism almost exactly like this. So it's just general handy programming. Any questions on the streaming?
So this is like you said, you're piping it, and if you were to just do it, the normal R way would be reading in that big text file.
Yes. Yeah, so the normal R way is to read.table, that file, bignormal.txt, and that is fatal for large enough data. It won't work. So you read it in, and then you subset it to find those ones that start with 2, pick them out. That's that.
And suppose it's a CSV file that's really, really big.
Mhm.
So can you type through a CSV file
Yes.
choosing particular column?
Yeah. Yeah, any kind of text table format, this will work for, and work pretty efficiently. Yeah.
Sorry. So if when you're using that pipe, that pipe's in R, is that right? So that all that code is running.
Right. This is our code.
And so when you pipe in and it gets that first value and it's gonna dump it after, it's gonna get that first value and then it's gonna dump it. Is that right? So then if you wanna do something with it, maybe I should ask more generally, what, if you wanted to do something with all those 2 values, would you do it in this way?
Yeah. See, I have these in my R session on the right-hand side. Okay, look at the head. I have them in data frame. Now I'm free to manipulate them and do whatever with them. So yeah, this pipe was really more of something like an abstract file where you took the original file and filtered it down to only start with 2. And then you just read it like it was a regular file. And from our perspective, that's exactly what you get, a regular file that just starts with 2. All the processing work was done for you. Yeah, or at least the initial processing of filtering down. Yeah. Okay, want to see a more involved example? Hadoop? Okay.
What is Hadoop?
Hadoop is a cluster. So it's made to store very large data sets. So it's a cluster system really popular in industry. And what the basic thing it has is the Hadoop file system. So on this file system, this is a small SSD. It's got a couple hundred gigabytes, pretty standard. Once you start pushing the limits of that, you want a distributed file system. So you want many different computers to share the data, to split it intelligently between them. And that provides redundancy and potentially better performance. Like if you split it across 10 different machines and you're processing them on 10 different machines at the same time, this is a win for you. Yeah. Yeah, so
Is it free?
it's free, yeah. It's open source. Yeah, you can get it. I have installed it on this machine before and used it. And so that's Hadoop. It's mostly, just think of it as providing the underlying storage technology. And it provides a programming framework called MapReduce to where you have a function. And it's cool about R being a functional language, they have map and reduce in R. So you can use map and reduce. Conceptually, they're the same thing once you wrap your head around that functional programming, like we were talking about. It's the same idea. So Hadoop could be used to store terabytes, petabytes, lots and lots and lots of data. And it's free and cheap and everyone loves it and uses it in the industry. They have huge conferences about it, and I don't get it. It's not that exciting. It's just like, it's just a file storage format. Yeah.
It's interesting how it's free. I mean, somebody buying the computers, right?
Yeah, I mean, you have to, the software is free.
Uh,
Just like the R software is free.
But is it the whole concept that you're putting distributed data on a bunch of different computers?
Yeah,
all
but
across
those,
the
you have to own those computers.
You have to own them. Okay. Okay.
And speaking of that, that Amazon is really nice
Yeah.
for these sorts of things, and S3, especially for just getting into it. If you don't have, like Eric, you were asking about having a cluster or getting access to one. Amazon is a nice way to do it. That's how I kind of started with the micro ones, 500 megabytes of memory.
Titus Brown has been teaching workshops and he has a couple online on like half-day workshops on setting up Amazon web services on your own and setting up a cluster and setting up RStudio server. So you can run RStudio from like a web, if you want, if you're comfortable with that. You can run the command line. So it's worth doing. It's pretty cool. We just actually taught the data carpentry genomics workshop in Stanford using Amazon Web
Oh, cool.
Services to run all their analysis, and we pulled it into RStudio and did teaching people our stuff. So it's pretty cool. I haven't used the AWS stuff much, but it was pretty slick.
Yeah, right on that. I really like it.
Yeah.
Renting the stuff, because you're most likely not going to need it for a really long time.
I mean, that's the thing. Yeah, you can rent it for like just whatever you need to do, and then turn it off, which is important to turn off. But then, then it's basically then you're done and you have your data. So
If you had, here at the university, it's cheaper or it's freer clusters that the university has.
yeah, if you have access to something here, certainly go here. But it's more like, and actually, Titus was saying they actually use it for their own even university research. If you just get a ton of data and you need capacity right away to get it done, you can do that. But certainly, if you have a cluster available,
Right.
use that.
So we have a cluster available in the stats department. Lucky us.
Use cluster, right? Sometimes, yeah.
In Germany, probably.
Oh, yeah.
Your clusters in Germany?
Yeah, and it's like so secure, you can't log onto it remotely. So I have to like only use it in Germany. There's like a lot of hurdles to use it. It might be impossible to overcome legally.
Wow, that's
One of the hurdles being that you have to fly.
Yeah.
email the job to someone there, put it on. Wow. Yeah. These I was telling the fun way. I used them in Korea last summer. I was in Korea.
Nice.
Needed to try some things. It's just log in. Using the ones right in my building. Okay.
Okay, so let's do this example and then we'll sign up because otherwise the YouTube video gets unmanageably long.
Okay. Sure. All right. So I'll just walk through the code I have. So let me show you this. So this is the reason I'm doing this is because it's something I actually needed to do, and it worked out well. I was giving this talk and said, "Hey, you want a real life example? This is something I really have to do." So here we go. For District 4. All right. So I looked at District 4. I have all these gzip files. U-8 District 4. Okay, so when they're zipped up, they're 25 gigabytes. When they're unzipped, they're a few hundred gigabytes. Therefore, I can't really process them on my local machine. It's just too big, and plus I don't want to, it's just a bad when you're handling data that large on a little machine. So therefore, I'll put them on our Hadoop cluster and start working with them from there. So here I'll show you just how to do that in R. Okay. All right, and here's kind of the typical workflow. So the only thing I want to do is move them from this machine, from the one server where I'm at, which is Hassan, onto the Hadoop server. Then I can start analyzing them and using Hadoop. So this task is actually just transferring the data. Okay, and so let me show you the remote server. Okay, so I can log into the Hadoop server. Okay, I go over here and I make a directory called July. Say I want to pick out all the files from July and transfer those ones over. Okay, this is conceptually the task I want to do. And notice how when I did SSH over here, I didn't have to give it my password. You can set up things to where SSH will use your public-private keys that are in your directories to do it without a password, which is way better, way more secure. Use it whenever possible, especially if you're getting onto these machines very often. Okay. So to do this, and this is required for the SCP command. So the secure copy, just like you press CP in the terminal to copy one file to another, you can use SCP to do a secure copy from one machine into a different machine. Okay. Four. This is the way you go through and develop these things. This is my command line. So I just said secure copy this file, so I gave a relative path to where I am in the directory, to this remote machine using this login, so Clark F as me at Hadoop, and I want you to go copy it into that directory, home Clark F July. So when we saw the status bar as it's transferring this larger file over, and then it seems to be done. Okay, and let's do a sanity check and just check that it actually did get done. I look inside July. I just made that directory. I see the new file that I copied over from one server to the other. And so this is 0101. That was January 1st. It's not July. Let me just remove it. Okay. Now it's gone. And we have nothing in my July directory on the Hadoop edge node that I'm logged into. Okay, I'm back on my local server, other server. Two servers involved here. We are shelling between the two, going from one to the other, moving files from one to the other. So I verified that this command actually works. Okay, which is the first thing we should do. Now I want to use R to help me out with this. Okay, so I'll just do it like this. So I've opened R, I just pressed R to get to the actual terminal version of R. Alternatively, I could make this executable, or I could run it using RScript, like we talked about previously. But I'll just run it live so we can see what happens. Okay. I start out with a list of all the files, giving it an absolute path, just to make sure keep my sanity. So I have all these files that I potentially want to move over. But the reason I'm using R is to do something like this, to get some data processing capabilities, like this grep 7. You know, it's generally much easier to do this, like I said, in a programming language versus Bash. So I'm avoiding that. Doesn't work. So July has 31 days. I found 31 files. That seems wonderful. Okay. All right, so then I write a little function to do this copying over. So before I used the actual system call, which required me to paste the command together. So that is less portable and modular than the system2 command. So this can do things like adjusting for the operating system that you're on, if you're on various operating systems. So it just says call the SCP command. So go over to the system using that command kind of which, so pick that one out essentially. And copy from this name into this directory. So my source name, which is file, that file name, copy that into that directory. Bless you. All right, so let's run it and see how it works. Part 1. Okay. So now I run it from R. I'm inside R now, calling the scp command of July 1st. So it's inside this function, and the data appears to have moved over, which is great. It'll let me do my dirty mungy processing stuff in R. Cool. Okay, so I want it to happen to everything, so I can use a sapply, just loop over everything in July, all the file names, and copy them over to my remote server, please. Actually, since I need to do this, I might as well take all the files and copy them over. Okay. So this was the thing that I actually needed to do, and I'll just let it happen. I don't know what it'll look like, but our script backup file mover. Here we go. $5min, not regular file.
Getting bigger.
Hmm?
Getting,
Okay, good. It's behaving as I expected. Wonderfully. So this will take a couple hours, maybe. It's going to be really quick. So it'll take all these files and copy them over into the July directory. So I'll go over there and move it. But it was great. I was able to write an R script to do all this processing. And so I was talking about tmux being able to detach. This command is running. I don't want to kill it and stop it. I want it to just keep going like you were. Everything is great. So I quit out of here. Just detach my session. I can get back to it anytime I like. And let's just do a sanity check that it's working. Okay, so I go on over to the target where I'm trying to paste all these files. Up and paste. Here I am on my Hadoop. That's July. Okay, great. Got 9 files over there already. So each one takes a few minutes and yada. Eventually they'll all get over there. Okay, so there's my example with Hadoop. Any questions?
Could you go back to that session again?
I just did this command, tmux attach session T0. Yeah.
Zero is the number name of that session.
Yeah, it's the name of this session. Mm-hmm. And they just start out 0, 1, 2, 3, unless you give them different names, which is sometimes nice to do. So usually I'll do something like this. So like PEMS files or something. Okay. So now instead of being 0, it's called the PEMS files because those are the things that I'm working on. And this is also on the Hadoop server. I have tmux going over there too. Yeah, tmux is everywhere. Yeah.
Cool.
Okay, well, there's like a 10-second delay, so just make sure nobody has any questions online. But other than that. So the only question from earlier was how does R and R script get attached to your path? Does it just happen when you install R?
Yes. Yeah, it happens when you install R, unless you do something different when you install R, or you otherwise change your system. But if you're just clicking the defaults, that's a good idea. Let's go there.
Okay.
Move.
Yeah. Okay, so we're good.
Sweet,
You guys can
thanks.
tweet any questions you want. haven't answered them already. And then, yeah, but we're gonna sign off from the screen share.
Great. All right.
So you can go to that Google
Let's go.
Docs and go and stop broadcast at the bottom.